is not initialization. Clear? How do you tell the difference? Looking at them. How do you tell? You have to look at the data type. The data type is present here, therefore it's initialization. The data type is not here, therefore it is assignment, and so we have to go back and look at what was initialized for name 1 or name 2 or name 3. Is that clear? Questions about that?
So if we just put car in front of the bottom name 1, it'd be fine.
Pardon me?
If we just put character in front of the bottom name 1, we'd be fine.
If you put char in front of that, you would have a duplicate of assignment. You would have a duplicate name. So if you did right here, if I remember, if I think what you're saying, I think you're saying,
Yeah, just putting character.
put char there, would still be illegal because I'm trying to redefine something that's already defined in that case. Okay? I can only initialize something one time. I mean, that's what the word means. Oops.
Even though it's a lowercase p. Oh wait, never mind. Okay. It's already been initialized. Never mind.
Yeah, the data value doesn't matter. Okay. So here's some pictures that we've just been talking about. And so forth. The next topic area in the slides is ragged edged arrays. And I want to pick up a thread here probably Monday on this. But until then, I want to go back to this bit of code and make some modifications and look at some things. Supposing, first of all, what is this while loop doing? Do you remember the code from last time? I know it was a long time ago. dyptr1 is a chunk of characters plus 1 to accommodate a null. There's nothing in that memory that dyptr1 is pointing at yet. ptr1 is pointing at in, which means that ptr1 is pointing at Bob, right? We copy the address into the address ptr1, so we can do that assignment. It's just an address assignment. ptr1 is pointing at Bob. dyptr1 is pointing at nothing, but it's enough space to hold what's in. And we did some other things over here, and then we come down to this. And so what does this line actually do? Kelvin? What does that line actually do?
It puts the content of ptr1 into dyptr1.
And so what would you say that is?
What do you mean?
Well, can you give a name to it, a one-word name to what that does?
Can't think of anything.
String copy, right? strcpy. It's a short, terse way of doing it, not necessarily recommended, but is possible to do. Everybody sees that? Now, I want to make a slight modification to that. Well, let's walk through this first. I'm going to run it, and we have dyptr1 is here, or the comment here, ptr1 and dyptr1. dyptr1 is this address, and who knows what's there? We just evaluate. Debugger is just simply showing me what's there. Or PTR1 is this address, and it has Bob in it. This address, the 3308, where would we find that? I know it's in memory, but what area would we find that? Where would we find it?
Stack.
It's on the other end of the stack. It's actually in something called the heap. So it's in stack memory in the heap area where we do management of dynamic memory. Okay, so PTR1 is our source. DYPTR1 is our target. And then we simply take one step and we move PTR1 down because we incremented it, and we move DYPTR1 down. Notice that it's gone one down. Let's go two down. So we've got BO copied into the starting address where DYPTR1 began. I want to look at this address. So this address, the destination, is this address. If I scroll up one, I see the BOB over here. Can you all see that? Maybe not. Let me just spread that out just a little further. So BO, and then this address where this thing is located is the address A, right? It's where we are at this instant. And if I do another copy, I copy the B over to the location, the destination location here. Is that clear? You see that? What's going on there? And if I do one more, I copy the null out there, that's the 0. So we have 62, 6F, 62, and null. So we copied the string over, right? And then we'll just run through this to finish that off. And the output shows us that we don't have any memory leaks. So all is good. I want to change this now. Very simple, very minor little change. Put an extra set of parentheses in there. So predicting what that will do, what do you suppose it's going to do? It compiles, therefore it must run properly, right? Because it compiles. So what's it going to do? Kenan?
It's going to store B to the first one, then C, then D, then...
So we're going to start with Bob here, B, and this will never move along, will it? The pointer is not actually ever being incremented. This pointer is being incremented, but not this pointer. So, got a breakpoint there, so we'll start debugging. We have the same setup as before. And now, we have PTR1, that's cool, and we have DYPTR1, and if we use this destination, let me here. So this address right here, where this CD is the first address in this newly dynamically allocated memory that we got. This chunk of memory right here, allocated here, is now starting right there, and there's 5 bytes that we allocated, or 4 bytes that we allocated. Is that clear? Everybody's good with that? See where we are? Okay, so now if I step through, notice that the C changes, the B changes to C, I mean, and PTR1 moved down 1, so we're now pointing, the next one is here. We put a 62 in there, which was the letter B, copied the letter B over there, and then F11 again, we put a 63 in here, and we noticed that the source changed to a D. We're not moving this address at all, are we? Okay. So how long can I do this? When will this stop?
Imagine when it eventually reaches 255 and goes to the next one.
So eventually it'll go to 0, right? Eventually, what we increment this this thing to, splat, whatever, will increment to a null once it's wrapped all the way through the ASCII character sequence.